Hello everyone. Now here is another problem based on projectile motion. An object is projected with u equal to 10 meter per second, that is the initial velocity, and theta equal to 30 degree, that is the angle of projection, from point A as shown in the figure. So this is the starting point A with initial velocity u and angle of projection theta. Find the velocity with which it lands at B. So we have to find that what is the final velocity at point B. Assume the ground has the shape of parabola as shown. Now this ground is also having the shape of parabola. Now since this is projectile motion, so this will be having the parabolic equation. This is also another parabolic equation. Now there is a standard formula for this projectile motion path. So using this and using this, can we equate and correlate? Okay, now let us have a look at the general equation of projectile motion, that is y equal to x tan theta minus gx square upon 2u square cos square theta. Now in this we know u, we know theta, so substituting these two values we get it as x equal to tan of 30 minus 9.81 x square upon 2u, that is 10 square into cos 30 square. So this gives one equation. Now the equation of ground is also given, that is equation of parabolic ground surface, which is given as y equal to minus 0.4 x square. So these two equations can be equated. So we will get the value at point B, because these two paths are meeting at point B. They are starting at point A and then meeting at point B. So from equation 1 and 2 we get it as these two equations are equating. So x tan theta, that is 30 minus 0.0654 x square equal to minus 0.04 x square. So this will give you the value of x, that is 22.73 meter. This value of x can be substituted over here or here. Now since this is simple, I will be substituting this over here, so I will get the value of y. So this is the reference point or the start point, and these x and y then will become the coordinate for this point B, because it is in the point of intersection for these two curves. So after finding the coordinates, that is B, that is x comma y, so we need to find what is the velocity at point B. Now look at point A. It is having horizontal component, that is u cos theta, that is this along the x direction. Now for a projectile motion, the x component for velocity remains constant. So if the velocity over here, that is horizontal component of velocity, is 10 cos 30, so it will be same over here, that will be again 10 cos 30. Next, for the vertical component, for which we need to find the equation of motion. Now let us have a look that how we'll go further. Okay, so now we have got the value of x, so substitute the value of x in equation 2, we get the value of y, that is minus 20.66 meter. So this gives the coordinate of B as x comma y, that is 22.73 and minus 20.66. Now horizontal component of velocity is always constant, as we discussed earlier. So therefore at point B, Vx, that is the horizontal component at point B, is u cos theta. Now this u cos theta is the velocity at point A. Then this thing will give you the x component as 8.66 meter per second, that is along the x direction or positive x direction. Next, consider vertical motion under gravity, that is from point A to B. So v square equal to u square plus 2as. This is the vertical component of velocity at point B. This is the vertical component at point A, plus 2 into a acceleration, that is due to gravity, that is minus 9.81. S is the displacement from point A to B, that is y. So this whole thing becomes y, that is actually minus y. So solving this, we get the value of Vy as minus 20.748, that is it is acting downwards. Now we have got the x component, we have got the y component for the velocity at point B. So this will give the magnitude, that is v equal to vx square plus vy square, the whole under root, that gives the value of v or the final velocity at point B as 22.483 meter per second. And the angle between these two can be written as tan theta 1, if this is Vx, this is Vy, and this is theta 1. So tan theta 1 becomes Vy by Vx. So this will give you the value of theta 1 as 67.345. Thank you for watching.